As I wait for a new bench power supply to arrive in the mail, I decided to make a crude one with some stuff I had lying around to actually test out a project I'm working on in the meantime. Now for this, I've decided to use this guy right here. It's a very cheap but okay buck converter with a nice LCD display. I got this off eBay for $4. Took about 2 weeks to come in the mail. I can link it in the description for you below. It takes an input voltage of 24 volts and can knock it down to about 1 volt. I let it run for a couple hours, and there was actually minimal heat dissipation. And it can handle a decent variety of voltages as well as current, so that's why I say it's okay. I'm not too impressed with the build quality though. I bought this from a seller, and when I got it, I found out that the actual LCD display was mounted on an angle, which means it wouldn't close up nicely in the case. Normally I could just take my soldering iron, heat up those pins, and push it in, but I didn't want to do that. So that actually led to an issue with one of the tactile switches that changes the voltage on it. And if you look closely here, you'll see I actually had to cut the tactile switch just a little bit so the button would be functional, because without that, the screen being at an angle would push up on that button against the polycarbonate case, and you wouldn't be able to push the button, which is a huge loss there. But overall, it's not a bad unit. Like I said, I'm just going to use this for temporary things and maybe in the future for different applications. So my idea here is to take this thing and mount it on an old AC to DC power brick, kind of like this. So that way I can plug it in, slap it on my desk, and actually use it for a few things. This power supply order is probably going to take a couple weeks to get here. So I need something in the meantime, which is this little crude application right here, because I have a few things I want to test and work on while that's arriving. So the first thing to do would be, of course, to test this out. I already have, but I'll do that right now to show it working. Unfortunately, one thing I didn't mention is that this display came from China, and when I got it, I hooked it up to my bench supply at work and found out that the LED for the display doesn't work. Huge bummer. I'm not too sure why it doesn't work. I measured the voltage here, which is for the backlight, and it's getting the right voltage, but the LED itself doesn't work. That's not a huge loss though. It's kind of a cosmetic thing, because you can still see what the display says, but it kind of sucks at the same time because you want it to do what it's supposed to do, but it just didn't happen that way. So first, I'm going to take this. It's a Kodak power brick. It outputs 24 volts DC. The maximum voltage rating for this, which is what I tested it with earlier, 24 volts, to see how it would work. And it worked just fine. I dropped 24 to 5 volts to power USB device, and worked just fine. So I'm going to use this one right here. I wouldn't recommend going over 24 volts. I wanted to keep it within 20, but I don't want to buy a different brick. This is what I had on hand. It's for a Kodak Easy Share thing. I don't feel like buying anything else. So first things first, test it out. There we go. So as you can see 5.2 volts coming out. Realistically, it's probably a little different because I didn't calibrate it. But the display not being backlit is kind of unfortunate. Let's see if we can get a visible right here, so we can adjust the voltage going up to 6 volts. So let's put it at about 10.4 volts and see where it stands on the multimeter. Maybe I'll fix the backlight in the future. Like I said, I just don't really care right now about it. So we're at 10.4 volts here. So let's see what we're getting on the meter, and I'll calibrate this guy later. 10.7, so it's off a little bit. Not too much for the applications I'll be using for it, but I'll calibrate it anyways, just to be safe. So next step, let's take apart the AC power brick. Okay, so I've gotten the brick taken apart. It's typically pretty easy to take apart once you get it down to an exact science, but most of them, especially the older ones, are just two halves of a plastic case that are connected together using some sort of adhesive. What I usually do is I try to get a flathead screwdriver in there. Don't like doing that method a lot because you might actually damage some components on the inside. If that doesn't work, then move on to a vise. I just put the brick in the vise and keep tightening it along the seam of where the two plastic parts meet until the adhesive cracks. And from there, it's pretty easy to tear apart. So with that out of the way, easily the hardest part, we can move on to mounting the little buck converter thing here. Also, you can get a different buck converter and a different LCD display. Just do this yourself. I just hit LCD display. I hate LCD display. It's liquid crystal display. It's like ATM machine or PIN number. Pet peeve of mine. But anyways, you can get another buck converter like this guy right here. And get your own display and do it that way. But this was just $4. And it was just like one of those buys on eBay you see. And you just buy it just because. Literally just because there was no reason for it. So now I'm going to drill a hole exactly where I want the input to be ran. There's also some wiggle room here, so I can run some wire underneath this and it should be fine. Then I'll mount the display as centered as I can get it, and probably run 2 of these types of connectors in parallel with the screw terminal output, so that way I can have these on it instead of the screw terminal. I don't like screw terminal that much. I really dislike them because they just don't seem stable for me, and they're always loosen up to a point where like you can actually lose the screw. I don't like that, especially with these ones. I've gotten the screw to come all the way out. Good ones are designed not to do that, but this is a China product, so what can you expect? So I'll just take these 2 off of this and put it in the case, and run my wires on the outside of this case underneath it through the plastic, and attach that so that way I can have that nice setup right there. Right now I'm just soldering the input and output wires here. Pretty easy to do. I'm doing it without taking apart the case, so that way I don't have to take apart the case because it's held together really weird. It's a polycarbonate case. It looks pretty nice, but it goes together like a puzzle, and it comes in, like when you take it apart, it kind of falls apart. Because once I put it together and realized the LED didn't work, I'm not letting that go. I took it apart to see if I was getting any positive voltage where it should have been, and all was right. I guess it's just a bad LED. There's that. So there's my sets of wires right there. I'm going to go ahead and put super glue on these 2 bolts right here, so that way if I need to take it apart it won't be too hard, because this is going to be mounted like this. So if these stay in the same spot, I can unscrew it and screw it easy. But the wire here is just the perfect height. Like, it clears these 2 little lips right here. So this way when I go to finalize it, there won't be any added height pushing the unit up, and I can use 2-part epoxy to kind of shove all this and keep it in place, which would be kind of cool. So in my head, this looks like a pretty neat idea. I really wish the LED would work. I would love that. That would add to it a lot, but whatever. So now I'm just going to go ahead and super glue those 2 bolts down and hopefully get them to stay. Okay, so I got these screw posts soldered in. I wanted to use the pressure from actually tightening it to hold the wire down, but that didn't result in a level mount, so I just said screw it and solder directly to them instead. Solder flowed kind of nice. Next thing I'm going to do before I put this together is cover up these with some sort of epoxy, maybe hot glue to insulate it so they don't touch anything, because it looks like it'll sit directly over these 2 caps, and I definitely don't want anything touching there. So we'll have to do that, and then next I'm going to have to run the input for the power from the output of the brick. And I don't want to have to take this board out because it seems as if they use double-sided tape to kind of push everything in place. So I don't want to do that, so I might actually clip the wires probably here and see if I could solder maybe to these 2 wires right here, and just use some heat shrink and insulate it that way. So that way I don't have to take this board out. Which is something I really don't want to do because this board seems like it's in there quite well. So I'm going to do that. Hook that up. With any luck, the pinout on the PCB is correct. It should be. I don't see why it wouldn't be. So then after this is all said and done, I'll glue this thing together. I'll glue the module down and then glue the case back together. So I have a lot of play inside this case, but I'm going to go ahead and clip the wires I'm going to solder to right about there. That gives me a decent amount of room to work with. I'll strip a little bit, and I'm going to strip some wire from this. Hopefully I don't peel off the casing entirely, which I didn't. Cool. And again from down here. One other thing that would be cool to add to this would actually be a slide switch to turn it on and off. I do have a little mount here for where the DC out came, so I might add a slide switch to this. I'm not sure. If I do, I'll just have to interrupt the power and ground. Not a big deal. It helps that they're both right here, so I could just easily do it that way. So there's that. I'm going to get some heat shrink. So we have 2 variety packs left, so I should have something close to that gauge. Insulate it good. Let's see what I got here. Oh, this looks good. This looks real good. So I'll use this. So I use this size heat shrink right here. That'll fit just fine. Cool. So now I'm going to go ahead and tin the wires that I'm soldering to. Up here. Good thing that came off. I don't want the heat of the iron to actually turn or to shrink the heat shrink, which is good. So now I'm going to clip up the heat shrink and make it even so I can distribute it between these. And then now I'll connect it to these right here, which shouldn't be too hard. It might be because I'm at a weird angle here. You're not going to see a lot probably. I apologize. But I can assure you it is a lot of fun. Okay, so for a quick recap, I have everything soldered up. The input going to the buck module and the output going to these 2 little screw posts right here. I have just the output wire soldered to the nuts that are mounted on the inside of the case for this. So now I'm tasked with closing this, which is going to be a lot of super glue, I bet. And a lot of vise, too. As you can see, it closes okay, but super glue is definitely going to be needed. Okay, so here the unit is. It's got some cleanup still. I let the epoxy sit for about an hour. It still needs to dry. It's a little bit malleable still, so it's not finished yet. But overall, it doesn't look too bad. I mean, it's a crude power supply, so what can you really expect? I think it looks kind of nice, given the fact that it was a DIY project in under an hour, which is pretty cool. Ignore this. This is super glued to my bench. It's been there for a while. But it doesn't look too bad for a DIY project. I kind of like it. Like I said, the epoxy is still setting, and in order to keep the display module in place while the epoxy is setting, I use some hot glue around the edges, and in about 24 hours I'll peel that hot glue right off and it should be fine. I also had to use some super glue around the edges of the case to get it to close because it was a very tight fit. The extra wires, there's four wires underneath this thing. The extra space those wires took up really made the case a little bit harder to close. This red positive output right here was actually sitting on top of a capacitor, so I needed to remove that cap and actually lay it within the board somewhere else so it would close nice. And overall, it's not a bad unit. If need be, I can crack it open again and re-glue it. But for $4, I'm not complaining. It looks really nice. Unfortunately, like I said, the display is lacking, the LED, so you can't really see it. Can't really see the display. Actually, I want to try something real quick. See if I can shine some light on it. Maybe force it out. It might not work. We'll find out. It made it worse. Yeah, the glare's not helping. But yeah, I mean, the LED being broken is definitely a bummer. But if I zoom in enough, angle the camera just right, you can see the display just fine. In person, it doesn't look bad at all. I mean, that LED missing in person is not really too bad, but on camera, it's kind of unfortunate. But yeah, here's the 2 screw outputs right here. That turned out really nice. All this gunk around the edges, that's all the glue that has to get removed later. I also have to clean off the sides of it too because there's a little bit of the glue residue and hot glue that dripped off because it's just holding the module in place until that glue dries. So let's test the output on this thing. As you can see, it says 16.9 volts. I'm going to try to sneak my multimeter in here as well so you can kind of see both screens. It might not work out well. So we can zoom out a bit. Okay, so that one says 16.9. I think I'll just find something to prop that up because the LED missing. Not cool. So 16.9, you can see that quite well on the camera. So let's see. I'll take my 2 leads here and I will put them in. We should get 16.9 plus or minus 3. I have to calibrate this unit still haven't gotten around to that. This is just a project I'm doing for fun on the weekend. So 16.9, 17.3 is what I'm getting on the actual multimeter right here that's reading the voltage output. So it needs to be calibrated, so let's see if we can change the voltage on this. And we're dropping down. Seems to be a quick change too, which is pretty cool. 11.5 volts. We could take this thing all the way down to close to 0. I don't want to, but we can. Let's see, 5.5. Seems to be good. Right there. 3.3 is also a good voltage to have because logic level runs at 3.3, which is pretty cool. So it needs to be calibrated still. Definitely. I'm going to hook up a load to this, but it's actually going to be in a future video. This is why I made this, actually. I need it for a future project, so if you want to see this thing in use and see the current meter go off, please subscribe and you will see this thing in use. I have a very fun repair project planned shortly after this video is released. I'll probably follow it, hopefully. It's a very unique gaming console I get to repair. So if you want to see this thing being used, stay tuned for that because it's going to use a voltage I don't really have on hand. Normally I use these transformer bricks. My bench supply is coming in the mail. I could use my one at work, but it's traveled back and forth. So I threw this thing together to use it for a future project. So if you want to see this thing under a load, subscribe. But this is as far as we're going with this in today's video. So if you like what you saw, please comment, subscribe. Constructive criticism is always welcome too. And I will see you next time for the next video. Thank you for watching.